I'm Christian Renfro, and I'm here today with Graham Rothy and Jack Depew, here to talk to you about the properties of moles and how they can be applied through chemistry.
You know what a mole is?
No!
Well, I'll teach you.
What are moles? And why are moles used?
Answer. A mole is simply a unit of measurement. Units are invented when existing units are inadequate. Chemical reactions often take place at levels where using grams wouldn't make sense. Yet using absolute numbers of atoms/molecules/ions would be confusing.
Like all units, a mole has to be based on something reproducible. A mole is a quantity of anything that has the same number of particles found in 12.000 grams of carbon-12. That number of particles is Avogadro's number, which is roughly 6.02 times 10 to the 23rd. A mole of carbon atoms is 6.02 times 10 to the 23rd carbon atoms. A mole of chemistry teachers is 6.02 times 10 to the 23rd chemistry teachers. A mole of Christian Renfro, Jack Depew's, and Graham Rothy's is 6.02 times 10 to the 23rd. Anyway, it's a lot easier to write the word mole than to write 6.02 times 10 to the 23rd.
Why don't we simply stick with units like grams or nanograms or kilograms, etc.? The answer is that moles give us a constant method to convert between atoms/molecules and grams. It's simply a convenient unit to use when performing calculations. Okay, you may not find it too convenient when you are first learning how to use it, but once you become familiar with it, a mole is as normal as unit as, say, a dozen or a byte.
Why we use this unit is to refer to a large quantity of things, or in simpler terms, a lot of stuff.
Understand what a mole really represents. We conducted this experiment.
Using dimensional analysis, we can convert pounds to grams and grams to moles. 161 pounds.
£165.
145 pounds.
We weighed 471 pounds!
So using dimensional analysis, we can find question mark moles equals the amount of pounds that we all weighed combined, which was 471 pounds. Now you multiply the pounds, whatever is on the top goes on the bottom. So grams over pounds. We know that 1 pound is equal to 453.59 grams. Whatever is on the top goes on the bottom. And now you have moles over grams. All of the labels cancel out. You have 1 mole over 6.02 times 10 to the 23rd grams.
We will show you later what that will equal, but we need a calculator.
Now when we grabbed our calculator, we typed in the equation, which is 471 pounds times 453.59 grams divided by 6.02 times 10 to the 23rd equals. Now we weigh 3.54885199 times 10 to the negative 19th. Wow.
You would need 6.02 chairs to make a mole.
He's wrong. You would actually need 6.02 times 10 to the negative 23rd chairs to make a mole.
He's wrong. You would actually need 6.02 times 10 to the 23rd moles to make a mole.
He's wrong. You actually need 6.02 times 10 to the 23rd chairs to make one mole.
He's right.
You would need 6.02 times 10 to the 23rd red zone to make you smell good.
Red zone. Stick it in here.
Oh hey, did you know you need this pencil and this paper and this calculator to do your calculations to find out how many things are in a mole?
Excuse me. How much of this do I need?
You need one more.
Are you telling me that I need 6.02 times 10 to the 23rd of that to buy it? What?
Open up your heart.